Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so in this video, today we're going to look into still a topic 2, first order linear of differential equation. But then in this part, we are going to look at the application of both of the, the method of differential equation discussed before in the previous lecture of 1 of 2. Separable variables, and second is integrating factor. Now we're going to see how both of the method being used in our daily life. So then, to solve problem involving first order differential equations such as Newton's law of cooling, electric circuits, population growth, and radioactive decay. Okay, so without wasting so much time, so the step in problem solving of DE, first define the variable. For example, the function of x with a variable of t, and write the proportional equation. Proportional equation mostly given in the question in the term of k. Mostly it will be given in the question. Then integrate x respect to the t, then substitute these two of t and this one here will be given in the question, because we need to find the constant of c and also the constant of k, and then solve the rest of the question. Okay, without wasting so much time, the rate of decay for a radioactive substance is proportional to the remaining concentration, which is given by the differential equation of dx dt equal to negative kx. Okay, so radioactive substance. If we refer to physics, that radioactive substance has a term of what we call half-life. Am I right? And then, if you find, let's say, 1 kilogram, for example, of any radioactive substance, and after a few times, it will remaining half of the 1 kilogram from the previous amount that we found earlier. Okay, so the rate of decay mean then, because from the beginning and until at one time it come up half of 1 of the kilos, might be that half of it is disappear. So then we come up with the sign of negative, meaning the weight is the weight after is lesser than the weight of the previous of the earliest time. So the rate of decay of radioactive substance is proportional to the remaining concentration, because the weight is less than the previous, then come up with a sign of negative. Okay. If 1/3 of the substance still remains within 12 years, how many percent of the substance is still available after 3 years? Okay. So t equal to 0 is not times 0, okay, but then just imagine that if this is one of the experiment that you held in the laboratory, so then we get one amount of radioactive substance, and we write down in the notebooks that the beginning of the day and the time of the experiment, we put the t as an equal to 0. So if 1/3 substance remain, 1/3 of the earliest amount of the substance within 12 years. After 12 years, then we back to the lab, we found that the weight is 1/3 of the the earliest. So then, how many percent of the substance is still available after 3 years? Okay. Now, So then the equation given to you, let's say let x with a variable of t, which is concentration of radioactive at time t. Okay, let's say given that dx dt equal to negative kx. Using the method of separable variables, this is just a constant of negative k, so this is the one. We are going to put this one here in middle of this. On left side, we assume that this is a house of x, and then this is a house of t. Okay, because the changes of the radioactive substance related to the time, okay, respect to the time of t then here. So then bring an x here, we come up with 1 over x dx and negative k dt. Okay, so integrate left and right. So you come up with natural log of x and equal to negative k. Okay, just imagine for this one here, negative k dt, integrate of this. So this is just a constant. So take it outside, negative k integral of 1 respect to the t. Then we come up with negative k t plus c. Okay, so we bring all this one here, negative k t plus c. Okay, let's simplify this. We come up with, if we come up with the constant we call the Euler's constant of E with a London here, then we come up with the x equal to e power of negative kt plus c. And this one here, negative e power of kt. Remember this? The a power of n plus n equal to a to the power of n times a to the power of n. So implied here, we come up with e to the power of c and simplified as a times e to the power of negative kt, where a equal to e to the power of c. Okay, why this e is a constant, c is a constant, a replacing these two as a constant to just like 2 to the power of 3. That is 8, right? Okay, so just imagine that e to the power of c equal to a here. Just imagine that, okay, as an example, not exactly the same as this one here. So then, x equal to a e power of negative kt. So then, given that, when x, okay, when t equal to 0, okay, when t equal to 0, not the time is equal to 0, but then t equal to 0 means that the beginning of the experiment on that day, on that particular day, and on the time that we write down on our what we call experiment book. Okay, so when t equal to 0, then x equal to x naught. Okay, so look at this one here now. When t equal to 0, x equal to x naught, and this is the equation that we found just now. Okay, x equal to a e power of negative k and t. Okay, so in this case, okay, from here to here, with something like, if I write down what we call simple notes here, from this step here, where e to the power of natural log of x, that is equal to an x. Okay. Now, back to this one here. When x equal to a e power of negative kt, and when t equal to 0, the earliest of amount of the we call relative substance here x, and we consider as an x naught. So substitute x with the x naught here. X naught equal to e to the power of, okay, x naught equal to a e, okay, a e power of negative k, and t equal to 0. Okay, so negative k times 0 equal to 0, e power of 0 equal to 1, and 1 multiplied with the a equal to a. So a equal to x naught. So substitute a here with an x naught, then you come up with x equal to x naught e power of negative k and t. Okay, that is the first thing that we found from the first information given here. So then now, when t given in the next question here, I rewrite x equal to x naught e power of negative k t. The next information given here, when t equal to 12 and x equal to 1/3 of the earliest amount of the relative substance. Okay, we substitute x here with 1/3 of x naught. 1/3 of x naught equal to x naught e power of negative k, and t equal to 12. So then divide by x naught here, divide by x naught left and right, then in left here 1/3 e power of negative 12k. So we are going to simplify this equation by come up with a natural log. Natural log of 1/3 equal to natural log with an e. Okay, natural log e power of negative 12k equal to negative 12k. Okay, because ln is a log to the base of e, then e to the power of negative 12k. So bring this front here, negative 12k, and log e to the base of e equal to 1. Okay, now we are going to find out what is the value of k here. So then k equal to natural log of 1/3 divided by negative 12. Okay, you may recall, press the button of your calculator and make this form of a function here. Natural log of 1/3 divided by negative 12. Okay, so if you can see from here, okay, it is, value of k is 0.092. Okay, it is 0.091551. So to 3 decimal places, I make it as 0.092. So then now, guys and girls, the equation of this x equal to x naught e power of negative k, which is 0.092, and t. Okay, then the next question is, how many percent of the substance is still available after 3 years? So please refer to the question in your lecture notes again. So how many percent of the substance is still available after 3 years? So then after 3 years, then t equal to 3. Okay, so this is the latest equation. We can see here now Previously, this is the equation that we get earliest, which is x equal to a e power of negative kt, where we have found that the constant of a equal to the earliest amount of the radioactive substance and k equal to 0.092. Okay, now after 3 years, then x equal to x naught e power of negative 0.092, where t equal to 3. So look at this one here now. When t equal to 3, so we substitute t with 3 here. Okay, and focusing on this, e power of negative 0.092 multiplied with 3. Okay, for this one here, x naught, and the amount of this, you may use your calculator, press the button for e and to the power of negative 0.092 times 3. Okay, so then I get it just now. Wait a minute. For e to the power of negative 0.092 multiplied with 3, okay, I use the photomat. So here, okay, I get it just now, which is 0.758813. Okay, so then the question was us to find out what is the percentage, okay, left after 3 years. So how many percent of the substance? So when it comes to how many percent, means that from this amount we multiply with 100. So then the amount of the, we call the radioactive substance after 3 years, which is 7588813, make it 2 decimal places here, which is 76% from the amount of the earliest of the radioactive substance. Okay, so left, which is thus after 3 years, then the remaining substance, which is 0.758813 x naught, okay, times with 100 here, then it is equal to 76%. Okay, which I think that I don't have to write all this. So then after the 3 years, the remaining substance is 76%. Okay. Next question. An object is released from rest into water. After t seconds, the velocity Vms minus 1 power of negative 1 of the object is given by the differential equation of dv dt. Okay, the changes of the velocity respect to the time, okay, equal to g minus 4v, where g is a constant. So now look at the question here now. Show that v equal to this one here. Find the velocity of object. Sketch the graph. Okay, so the first one here is given then dv dt equal to g minus 4v. Okay, so g is another constant here, so dt bring up, they come up with 1 over g minus 4v equal to dt. Just imagine that there is 1 here. Okay, dv. Okay, so we integrate left and right and come up with natural log of g minus 4v integral of 1 over, and we call the linear here, which is ln g minus 4v, and derivative of g minus 4v, because in this variable we are looking at a v here and also t. So then it has nothing to do with g. G is a constant that out from our discussion of v and t here. So then derivative of this equal to derivative of g minus 4v respect to the v equal to negative 4. So we come out with negative 1 over 4 here equal to integral of this equal to t plus c. Okay, so then natural log of g minus 4v equal to negative this one, we are going to multiply with negative 4. So cancel between negative 4 and negative 1 over 4 here. So they come up with negative 4t minus 4c. And use recall the constant of e. Just imagine that if we come up here and also here. Okay, so cancel these two, g minus 4v equal to e power of negative 4t minus 4c. Okay. Okay, again look at this one here. E power of negative 4t times e power of negative 4c. If I change this in the form of a e power of negative 4t, where a equal to e to the power of negative 4c. Okay, so then here now equal to a e power of negative 4t, where a equal to e power of negative 4c, then g minus 4v equal to a e power of negative 4t, so negative 4v equal to a e power of negative 4t minus g, and v equal to, okay, multiply with negative 1 over 4 or divide by negative 4 here, left and right, and come up with 1 over 4 g minus a e power of negative 4t. There you go. Okay, please refer to the question. The first question showed that v equal to g over 4, 1 minus e power of negative 4t, which I think that we leave it something like this. Okay, we are going to, no, this is not the final answer. This is not the answer for question A yet, because we are going to substitute the first information from the given, then when t equal to 0, then v equal to 0. So v equal to 0 and t equal to 0. 0 equal to 1 over 4 g minus a e power of negative 4 and 0 here. So negative 4 times 0 equal to 0, and e power of 0 equal to 1. So then 1 over 4 g minus a, okay, from here we multiply with 4 on the left and multiply with 4 right here, still remains 0. 4 divided by 4 equal to 1. So then G minus A equal to 0, then G equal to NA. So then, and G equal to NA, for this one here now, back to this equation, V equal to 1 over 4 G minus GE power of negative 4T, then V equal to G over 4, where we have G here and G here. So we factorize, take a G outside, multiply with 1 over 4, become G over 4, then 1 minus E power of negative 4T. Okay. Then the next question, question of number 2, find the velocity of the object when t approaches to positive infinity. So just now, v equal to g divided by 4, 1 minus e power of negative 4t. Okay, so when t approach to positive infinity, then v, okay, so then as t approach to infinity, then e power of negative 4t approaching to 0. So thus then v equal to g divided by 4 meter per second. Okay, so this is the graph. Okay, so the graph from, we call t equal to 0, and also we call the velocity is 0 then, and then so this one here at g equal to 4, then the velocity, which is g over 4, 1 minus e power of negative 4t. Okay. And question number 3. Question number 3. What's the question just now? Sketch the graph. Okay. Which means that here, this answer for question number 2, and this is question number 3. Sketch the graph. And show that the distance traveled by object in first 5 seconds is about 19 over 16 gram. Okay, 50 g. So then, solution for question number 4. Okay, v equal to ds dt. Okay, the changes of s respect to the time, which also we have found it just now, which is g over 4, 1 minus e power of negative 4t. So integrate, we call this one here ds equal to g over 4, 1 minus e power of negative 4t dt. So bring dt here and integrate left and right. Okay, so this one here now, if is 1, integral of 1 ds equal to g over 4 is a constant, and we integrate just this one here, 1 minus e power of negative 4t dt. Okay, and then s equal to g over 4, which is t plus e power of negative 4t divided by 4. Okay, this one here is just like integral of 1 minus e power of negative 4t dt. equal to integral of 1 dt minus integral of e power of negative 4t dt. Integral of 1t equal to t, okay, minus e power of negative 4t divided by differentiate the derivative of negative 4t, negative 4, okay, plus c, there's no c here, okay, t negative with negative become positive, e power of negative 4t divided by 4. There you go. So this is the, we call the process of getting this here, okay, and then plus c. So when t equal to 0 and s equal to 0, okay, s0 here equal to g over 4, t equal to 0, 0 plus e power of negative 4 times 0 divided by 4 plus c, okay, e power of 0 equal to 1. 0 plus 1 over 4 equal to g over 4 multiplied with 0 plus 1 over 4, 1 over 4 plus c, which is g over 16 plus c equal to 0. So then g over 16 equal to negative g over 16 equal to c. Okay, c equal to negative g over 16. And then when t equal to 5 and s, so this one here, s equal to g over 4, okay, 5 plus e power of negative 4 times 5 divided by 4 minus g over 16. This one here, g over 16. Okay, so e come out with 5g divided by 4 minus g divided by 16. Then s equal to 19 over 16 g. Okay, so that is a solution for question example 2. Okay, a community consists of 1,000 homogeneously mixed individuals. An individual who just returned from another community has influenza. Assume that all are susceptible and influenza spread at a rate in direct proportion to the number of n who have it and the number of 1,000 n who have not yet contracted. Mathematically, the differential equation is given here. Okay. The changes of the numbers of the people in community respect to the time equal to this one here, where n is the number of people. Okay, n is the number of people who have contracted influenza after t days. For k equal to 0.0004, now show that n equal to the equation here. Okay, so which I think that you may refer to the notes that you have in your hand right now. The question of how many people contracted influenza after 10 days and all this. Okay, now it's given a question right here, dn dt equal to kn and 1,000 minus n. Okay, so now is we call the variable is between the n number of population respect to the time. And if you see here, k with an n and also n, meaning this all we call the statement for the variable of n here. So then 1 divided by n and 1000 minus n dn equal to k dt. Bring up here k dt. Okay, so then integrate left and right. But before that, okay, class, before that, for this one here, we need to make some, we call extra work. For 1 divided by n, 1000 minus n, so additional works here, we need to write this in the form of partial fraction, which is 1 over plus n, and then over 1000 minus n. Do you still remember this? Good. Okay, now we assume that there is an a and b. A divided by n and b divided by 1000 minus n. So just imagine that we need to find out the value of a and b. But before that, before we compare a and b with 1 here, we need to equalize the denominator of these two with the original question. So just imagine that we multiply this with 1000 minus n and also 1000 minus n. So this one here now with n and also n. So for both of this, okay, this is the partial fraction that we formed just now. Okay. So now we compare the numerator since that the denominator of these two are already equal with this one here now. So 1 equal to a 1000 minus n plus with b n. Okay, so then 1000a minus a n plus with b n, or okay, b plus a with a variable of n, and then no, b minus a, sorry, b minus a with an n and plus with 1000a. So here we come up with 0 and 0 multiplied with n plus 1. So it means that here we compare this 1 with 1000a. 1000a equal to 1, then a equal to 1 over 1000. Okay, so then b minus a equal to 0. B minus a is a coefficient of n, and 0 is also a coefficient of n here. So b minus a, where a is 1 over 1000, equal to 0. Then b also 1 over 1000. Okay, so rewrite this 1 over n 1000 minus n equal to a, okay, before that, where a is 1 over 1000. A is 1 over 1000, so 1 over 1000 n. A divided by n, where a is 1 over 1000, so 1 over 1000 n. And plus with b is also 1 over 1000 multiplied with divided by this. So 1 over 1000 and 1000 minus n. There you go. Okay, so look at this one here now. 1 over 1000 n plus 1 over 1000 multiplied with 1000 minus n. Okay, so we got 1 over 1000, 1 over 1000. Take it outside. We call factorize this. 1 over 1000. Okay, and then this is 1 over n plus 1 over 1000 minus n. Okay, so this is the one that we're going to substitute here. Don't forget that the purpose, or we come up with all this, we need to find out the value of a and b, and we already found it here now, and this is the one that we're going to substitute here. Okay. So in that case, it's just like integral of 1 over n 1000 minus n dn equal to this one here. Okay, integral of 1 over 1000 1 over n plus 1 over 1000 minus n dn. Okay, so then it is, take it 1 over 1000 is a constant, so then 1 over 1000 integral of 1 over n plus 1 over 1000 minus n dn. So it is now equal to, okay, and this one represent this. And don't forget that we compare this equal to k dt. Okay, it is 1. Okay, so we already found that we call this 1 over n times 1000 minus n in the form of partial fraction. We already found that a and b, and we had write down this in this form here. So next, integral of 1 over n 1000 minus n dn equal to integral of k dt, and this one we found that in the agree that we have found this in the form of 1 over 1000 integral of 1 over n plus 1 over 1000 minus n dn equal to integral of k dt. Okay, so then 1 over 1000 integral of 1 over n natural log of n plus this one here natural log of 1000 minus n, and derivative of 1000 minus n respect to the n equal to negative 1. Then k, integral of k, k taken outside here, integral of 1 dt here, kt plus c. Okay, so simplify this in the form of natural log of n minus natural log of 1000 minus n equal to 1000 kt plus 1000 c, or another c is still a constant. Okay, whether you write down this in the form of c, because we write down here, okay, just imagine that we're going to eliminate this, so we multiply with 1000 on left and 1000 on right side. So 1000 multiplied with 1 over 1000, 1000 multiplied 1 over 1000 is 1. So multiply with 1000 on right side here, 1000 kt plus 1000 c, or you may just put it another capital letter of c, where c equal to 1000 c. Okay, it's still the same because it's still a constant. Okay, now, okay, so this one here now, I'd like to simplify this on the left side. Okay, so natural log of, using the logs rule, log a minus log b equal to log, yeah, okay, still remember a divided by b, good. So what about this one here now? Natural log of n divided by, yes, 1000 minus n equal to 1000 kt plus a capital of C. So come up with the E constant of E here and also E here. Okay, and cancel between these two, then n divided by 1000 minus n equal to a e power of 1000 kt. Okay, where a equal to e to the power of c here. Okay, actually that this one here. Okay, we'll simplify this. E power of this plus c for a power of n plus n equal to a to the power of n times a to the power of n. And for e power of c here, we simplify as an a. Okay, now the first information given in the question then, when t equal to 0 and n equal to 1, where n equal to 1 and 1 here, so 1 over 1000 minus 1, 999. Then a, okay, no, sorry. A e power of 1000 k, where t equal to 0, 1000 k times 0, 0, and e to the power of 0 equal to 1, 1 multiplied with a, so meaning here, a equal to 1 over 999. So substitute a, the value here, then n divided by 1000 minus n equal to 1 divided by 999 e power of 1000 k nt. Okay, now we bring this to the next page. N divided by 1000 minus n. Okay. N divided by 1000 minus n equal to 1 over 999 e power of 1000 kt. Okay. So given in the question again, where the value of k equal to 0.004. So then n divided by 1000 minus n equal to 1 divided by 999 e power of 1000 k 0.0004 nt. Okay, class. So look at this. 1000 times 0.0004, which is 1 over 999 e power of 0.4 t. Okay. Okay, in this one here now, we just want to imagine that if we multiply 999 here, so 999 multiplied with 1 over 999 cancelling each other then here, so multiply 999 on the left side, or bring this to the other side. So n divided by 1000 minus n, so cross multiply 999, n equal to 1000 minus n e power of 0.4 t. Okay. Expand this. 3000 multiplied with this one here, 1000 e power of 0.4 t minus n e power of 0.4 t. Okay, so we get n and also n here. So bring this to the left side. 999 n negative become positive, plus n e power of 0.4 t, okay, equal to 1000 e power of 0.4 t. Okay, then factorize these two. We get n is similar here. So then n 999 plus e power of 0.4 t equal to 1000 e power of 0.4 t. Then n equal to 1000 e power of 0.4 t divided by 999. Bring this to the down here, plus with e power of 0.4 t. Okay, now we try to multiply with we call the conjugate of e power of 0.4 t with e power of negative 0.4 t and also e power of negative 0.4 t. Multiply with this one here. I'll bring up here, sorry. Equal to e power of 0.4 t multiplied with the conjugate e power of negative 0.4 t equal to 1000 divided by this multiplied with this one here, and then this one multiplied with itself equal to 1 plus 999 e power of negative 0.4 t. There you go. Okay. And last final question mentioned there. Find the limit of n respect to the t when t approaching to infinity. So now, where n equal to 1000 divided by 1 plus 999 e power of negative 0.4 t. So then when t equal to 10 and the n given then here, where n equal to 1000 divided by 1 plus 999 e power of negative 0.4, and where t equal to 10. Okay, so then 1000 divided by 1 plus 999 e power of negative 4, which is 51.8. You may press a calculator to get answers of this one here, so approximate to 52 people. Okay, and then okay, so this is a solution for question of A. Okay, after we find out the n in the, we call the equation of n here, so this is first question of A. And then from 1000 of the population from the beginning of the question that here, so then when n equal to half of this, which is n equal to 500, then t, which is 0.4 t equal to natural log of 999. Okay, class. For question of B, when n equal to 500, which is half of the earliest of the population that we contract by the influenza, then here, when n equal to 500 and t, okay, suddenly I gave you all this one here. Supposedly if I gave you the idea from where we get all this from here. Okay, so n equal to 1000 divided by 1 plus 999 e power of negative 0.4 t. Okay, just imagine that if n here is 500, at the moment we're talking about n which is 500 here. So imagine that we bring up all this, the denominator to the left side, and 500 bring up here. So 1 plus 999 e power of negative 0.4 t equal to 1000 divided by 500, which is equal to 2. Okay, then 1 bring up here become negative 1. So 999 e power of negative 0.4 t equal to 2 minus 1 equal to 1. Then e power of negative 0.4 t equal to 1 divided by 999. Okay, might be this one here different from this one, different from this, because if I straightly get referred from here, then t equal to natural log of 999 divided by 0.4, and it is going to give you 17.2668 and so on. And from here, natural log of e from the left side, and also if I just imagine that if I put a log here, so cancelling between these two, then negative 0.4 t equal to natural log of 1 over 999, and t equal to, actually that t equal to natural log of 1 over 999 divided by negative 0.4, also gonna give you 17.2668. Okay, so it means that here t equal to 17 days. Okay, so finally here, when t approach to infinity, then e power of negative 0.4 t approaching to 0. So the limit of t approaching to infinity of the equation of n with the variable of t here equal to the limit of t approaching to infinity of 1000 divided by 1 plus 999 e power of negative 0.4 t, okay, equal to, okay, when t approaching to infinity, so everything here approaching to 0, so 1000 divided by 1 equal to 1000. Okay, so class, might be for this topic of application of differential equation from my lecture here might be a little bit confusing sometimes, because it needs you to take time to understand the situation and use the information from the question slowly one by one. So please refer to your reference books and some other reference books that might help you to continue with your tutorials and past year questions. So that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.